sourcing. Marco Heimeshoff, please come on stage. And I truly apologize for this.
Thank you very much.
And you'll do much better than me.
I hope. Thank you very much. Welcome, everybody. So I'm glued to this notebook today because the clicker doesn't work, which means you have the perfect place to not see me at all. Welcome, everybody. Today I want to talk about bounded contexts and team topologies and architectures and how you can align both of them. So this is a concept from domain-driven design. Has anyone heard the term bounded context before? Quick show of hands. Wow, that is a first. Everybody. Okay, awesome. Yeah, this is me. We've heard about me enough. We don't need to adhere to that. So we have a big problem in software development, and this is a problem with misalignment. And you can probably guess what the misalignment is all about, right? We just talked about team structure of your company and the software architecture you're building. So why is it a problem to have a misalignment there? Well, looking at this, I hope you can all see it properly. Looking at this graphic, you have your team structures, different kinds of teams working in relation to each other, and they are serving a problem, solving a problem, serving maybe as well, but they're solving problems by building software. Now, if the software structure isn't really fully aligned with the teams, this is the so-called socio-technical misalignment. We get a problem in dependencies. Meaning if you have, for example, a UI team, right, that makes all the UIs happen, but then you have multiple services, they all need user interfaces, you have a team that's all of a sudden depending on every piece of software that needs to change. This and further complications in all kinds of directions will hinder you from moving as fast as you possibly could. Now, there's a book called Accelerate. It's a really good and scientifically based book on DevOps culture. And the basic idea here is to say that a loosely coupled architecture in your software, where things are not deeply integrated but loosely coupled, that matches the organizational structure, is a key predictor of continuous delivery performance and the ability to scale your organization properly. So this has various reasons. Conway's Law is one of them. Has anyone heard of Conway's Law before? Yeah, why am I even asking? Like, why are you in my talk? Okay, great. So you already know we're doomed to build systems that reflect our own communication structures. Or doomed or presented with it. It's a challenge and a chance at the same time. But this is not the only dependency we have. There's also the domain at hand that we are solving problems for, right? So we not only have the socio-technical relationship, we have a domain technical relationship and also a socio-domanical relationship. I'm coining this term now. There are different kinds of dependencies in all these directions and different kinds of alignment that we can optimize for. So aligning the domain with the team topologies means if you're serving for something like, let's say, an airplane company, you have a reservation system and you have seat selections and you have payment, advertisement, all that jabang. The software systems you're building should reflect that on the one side, and the teams that you want to have should optimize for those contents, right? We don't want to build a team that is purely focused on a technicality, but they should be focused on a slice through the entire domain. Now, we have a problem here, and the problem is inertia. I'm not going to ask who knows what inertia is, but to give you a quick definition, inertia in physics means the resistance to change, right? You want to change direction, so you need to exert some force, and every object in motion stays in motion unless acted upon. Inertia in social and technical systems is a relative resistance to change. So if you want to move someone to change structure, it takes effort, it takes time. There's inertia built into all these relationships. Now, what are the reasons for the different kinds of inertia we have? On the architecture side, there's legacy systems, right? You're trying to say, hey, we should change the software, let's quickly do it. Welcome to software. Forget about it. Some pieces of software will stay the same for the next 20 years. Some will never change, right? I've heard this morning that somebody's using AI to use COBOL code and make new code from it, but yeah, good luck with that. Kent Beck. Then there's vendor systems, right? You're integrated with vendor software. Not every part of your system is built by yourself, and you can't just call up a vendor and say, hey, could you quickly change this because we need it differently? You have to enforce a lot of force or incentivization to make some changes happen. And then there's also the shiny new toys. I mean, most of us are developers, I guess. I've been developing software for more than 20 years now, and I love my React and Fable and F# stuff. So if there's a new thing coming out that I like, I'm going to introduce it to my product. Awesome. That's not driven by any problem we're trying to solve for the domain, but it's fun. So developers like having fun at work. And if we're not challenged enough in our work, we're going to make our job more interesting by finding challenges we can solve then. So those are all things that keep us moving in a certain direction and keep us from changing in the direction we should. Then on the team side, why would teams change? Well, there's There is so many reasons, as many as there are people, but people grow, change their interest, right? I was a developer, now I want to be more of a manager. We've heard that in the talk before, or a leader, sorry. So there are various changes because people outgrow their challenges. Teams split up because they become too large. People start hating each other or loving each other. So I choose different people to work with or to not work with anymore. And then, sadly, in my life, I've seen this more than once. It's private equity, right? We are a great company, but now somebody bought us, and we're part of a larger conglomerate. Now we have to change things to make it fit again. Sadly, in the last few years, mass firings happened. So Twitter starts to have like 1/10 of their developer base, but still the same problem to solve. So how do we deal with that, right? The team topologies are in constant change, and this change is really hard to influence from the outside. So there's inertia baked into both systems. And then even the domain itself has changes baked into it and a direction that is hard to steer. So there's business strategy, right? The business wants to go in a certain direction. To change that strategy, you need a lot of effort. There's new insights about the domain. Like, we were trying to solve this problem. Now that we're at it, we realize there's a different problem that's more important. So we're changing strategy. We're getting new insights about the domain. A CTO is changing, which, well, this could actually go into the team topologies part or the domain part. Hard to say. This is a business strategy thing, right? But somebody is coming in that doesn't want to look stupid. They bring in new ideas and they steer the ship around. Customers' needs evolve. Customer needs new things now that the world moved on. So all of these things make a certain direction for the domain, for the architecture, and for the team structure. And all of this means, hey, when the domain changes, the architecture should adapt, right? We want to build software systems that really fit towards the problem space. But it's hard to do so because there's a legacy system and there's a vendor software. Now, if technology changes because we're using web components now and mobile apps, so we need our team structure to change. This is really hard because people are already shaped in certain teams. There are management structures that don't want to change. So everything in this entire trifecta is blocking change on the two other axes. And this is a major problem. So as every problem, it builds in some opportunities, and we can deal with that, but we must be aware that this is something that will never go away. We can only manage it and deal with the opportunities arising from this. So the biggest problem here is that the cost in software development, and this was a quote by someone, I forgot who said that. Oh, we have an update completed, cool. So the cost in software development is the cost of change. So initial building of something is, of course, not for free, but that's not the expensive part. But once you've generated some structure and you want to change it, that becomes really, really costly. And the cost of change is almost always depending on the degree of coupling. That means the more your teams are coupled amongst each other, the more your technical components are coupled, the more coupling you have, it's harder to change things, because when you change it, the other side of that coupling is now suffering, so they will put inertia back in and say, hey, slow down with the change. We're not ready for that yet. So what we're trying to do is to get systems as decoupled as possible. And you will never get completely free of coupling, of course, but what we want is have a strong alignment with the domain, because the domain is the thing that we actually solve problems for. That means if we align our architecture on the domain technical axis, alignment in this area gives us very high cohesion and low coupling on the technical level. Meaning, if I have, instead of a database team, a UI team, and a logic team, if I have a team for reservations, and an architecture for reservations, and I have an architecture for the payment system, I have different services or different components solving these problems. When the domain changes, the alignment is already in the correct stage. We can say, oh, this is now splitting from a business point of view. The domain model changes. The architecture has the shape of the old model. Let's just split it in the same way. That's not for free, it is effortful, but it's the lowest amount of effort that makes sense. If your software architecture would be shaped any other way, you would now have to figure out, like, oh yeah, this is changing, but that doesn't reflect in our architecture. How can we make this reflect this? This becomes really hard. So we want to have high cohesion amongst our architectural models. Then, if the team topologies, if the structure of the teams align with the software components that are also driven by the domain, we get high empowerment of our teams to deliver actual value. So some areas of the domain are built in a way that they only need to be maintained, right? You have, let's say, a payment system that just works. How often do payments rules and behaviors change? Right? Very rarely. Sorry, there's an expert in the back. It's like, no, 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 they do. Okay, sorry, I'm not an expert here. But there are parts of your domain where change is rare and where quality of compliance must be high. So you need a different mindset than in an area of a domain where you don't know yet what customers need, where you need to be more experimental. So you can have different teams focused on the abilities they need to have to solve problems in the architectures based on the part of the domain. And then, on the last axis, between the domain and the teams, if my teams are actually aligned with the structure of the domain, this is a strong motivator for the teams to become, well, independent leaders, right? We can now start to discover stuff within the areas we're experts in. Programmers and architects will become domain experts over time because we're not just building code, we're solving business problems. And if my expertise is actually, hey, make the best reservation system possible, I'm going to start to learn all about reservations and understand the motivation behind the business problems we have so we can serve better solutions. And this makes us discover things more and actually strategize. So the development teams become part of the strategy leading force in the company. So this is why we want to align with the domain first, and then every other aspect is a follow-up of that because we are serving solutions for the domain problems. Now, that sounds all well and good, but this will never be stable. No matter how much you align, the stability here can never be achieved. The moment the system would be stable means nothing will ever change anymore, right? And that means software is dead, or business is dead, or whatever. So this will never be stable. That means there is also no metric we can go for or no method that will lead us to this promised land. We have to become adaptable. We must learn methods that keep us continuously adapting. And that means it's not the job of a manager to tell the developers what to develop. I hope nobody actually works in an environment like that. If so, talk to me later with beer or coffee. But what we need to do is we need to find methods and tools that help us to continuously adapt, learn about the domain, change our team topologies, change our architecture, and building loosely coupled systems based on domain-driven design is one of the key success factors for that. So let's talk about domains and bounded contexts. Now, I already asked, everyone knows what a bounded context is, so we can be quick about that. I've chosen the domain of flight booking. Not because I'm an expert, but because I'm not an expert, so I can really naively wing it here. So in my observation, I've been flying a lot lately. Sorry, planet. So the domain of flight booking has lots of things, right? There's marketing and sales. Somebody offers me a ticket through Facebook. I'm like, yeah, let's book that. And there is reservation happening. So there are domain experts who care about reservation. There's flight management, right? And the tickets, they get printed or scanned. There's a boarding phase within the airport. And there's a loyalty program. When I'm a frequent flyer, I can mess up the planet even cheaper. Great. So this is flight booking as a domain. And these are so-called subdomains. Now, what is a domain? Well, asking an audience that is mute is kind of mean. A domain is an area of expertise people can care for in isolation. So the domain of flight booking is something people care for, but within that domain, there's the domain of reservation, where experts care for, and you can hire an expert for reservation that doesn't have to care about how ticketing works. So with this is our domain. I've chosen one of those subdomains now, let's say the reservation here, and now we want to build a software system. And as you are aware, this is the anti-pattern, right? The building the classical three-layered architecture or any other kind of architecture for that matter, where you have things that don't really reflect the reservation but are optimized on technical constraints like experts for database, experts for messaging, experts for UI. That's not what we want. We want to build a software system that is cohesively solving problems within the reservation domain. So this would be something like a reservation service. Now, this is not a bounded context yet. This is just a reflection of the subdomain as its own thing. And there are various reasons why this might not be the best choice. So the domain experts, who are experts of reservation, right, they can understand the whole domain at large. If I want to build software solutions for this, I need to become an expert like the domain experts already are. I need to understand the entire domain, come up with better solutions, and understand how to build and maintain and operate a software system. So the level of complexity goes way up. We need to chunk this down into smaller, manageable sizes where mental load makes sense. And we can't build a single team that takes care of all the concerns within reservation. We need way more people for that, I'm assuming. I'm not an expert, but let's assume. So this is where bounded contexts come to the rescue. What we want to do is we want to figure out how can we split the entire subdomain into smaller mental models that serve specific purposes. So as a definition, what is a bounded context? And this is where it gets a bit tricky. A bounded context is not a piece of software. It's not just a code model. It's also not a team structure. It's all of those things together. A bounded context is a mental model with a clear boundary and a clear purpose in which language is very specific. That is a definition from domain-driven design about what a bounded context is, and this is one of the most helpful tools to align amongst domain architecture and team topologies. Because if we figure out what are the different mental models that we can extract from our reservation subdomain, we can put single teams on each of those mental models, let them build a single piece of architecture that solves the problems within that domain, and it's aligned with the actual needs of the stakeholders because it's reflecting of the domain structure. So for that, the boundaries must be clear. You can always tell what's in and what's out. The language is clear and it's maintained by a single team. Keep that in mind for the next phase. Now, we've put a little API design on the side here. So what happens between bounded contexts is only 3 different kinds of interactions. If you have multiple bounded contexts that interact, all they actually exchange are intent. So I want you to do something, which is a command, right? Events, I inform you that something just happened, so you can react to that. Or data, I'm just asking if the seat is still available, I get that information. This means no matter how often I ask, nothing actually changes, I'll just get the information. And this is in both directions. I can receive those or I can send those out. This is not saying it's messages, it's not saying it's method calls or anything, right? This doesn't determine how you build your architecture, but this tells you those are the only meaningful interactions between mental models. If they are social systems, I just give you a phone call, ask a question, or if I send a message on Kafka, same thing. This bounded context needs to know something from that bounded context. So this is how we can build our socio-technical architecture at large, building a network of those components called bounded contexts. So I have designed our bounded context system here to serve the problems within reservation. I've picked the seat selection as its own problem space, upgraded and insurance, so I want to have a flight upgrade to business class. I also want to get a car when I arrive, and I want to insure my flight, right? Those things have nothing to do with seat selection. We can build separate components for that, even though both are part of the reservation process. And then the payment in the end becomes its own simple domain. Looking at you. Payment is simple, I've heard. So let's take payment as an example because it's probably not that simple, right? From a business perspective, payment is easy. 15 minutes after you reserved a seat, you have time to pay. If you didn't pay, the reservation is canceled. If we receive the money, everything's cool. And we allow you to pay by credit card, PayPal, Bitcoin, World of Warcraft, Gold Coin. We don't care. Choose whatever you want. But as a programmer, I'm like, yeah, screw you. I'm not going to build one system that takes care of all of that. So if World of Warcraft servers now stop working, my Bitcoin system has to be redeployed. Like, why? I can build isolated components here, isolated mental models. So what we would do in those cases is build a bounded context that's called payment process, in which the actual business flow is defined, and then integrate that with smaller bounded contexts that take care of the intricacies of credit card fraud detection, Bitcoin hash value calculation, and so on. So by doing that, we're still having the shape of the subdomain. So all of this is within the same subdomain. We're still aligned with the domain itself, but we now have smaller and smaller components that are actually parts of the mental model of how the business operates. If we ever decide to not allow credit cards anymore, we can remove that bounded context, and the alignment is very high. We don't have to cut through the entire software that we're building. We have isolated mental models for that. Driven by the domain first, not driven by technical constraints first. Okay. So all of those different bounded contexts have a different value. Now, question for the audience again. Has anyone seen the core domain charts before? Ha! One person only. That's amazing. Okay, great. So I'm going to show you something new now. The core domain charts, invented by Nick Tune, is a very simple two-dimensional graph to figure out what should we focus on our most resources, where should we put effort, and which model should get more rigor and control within the overall architecture. So if we look at the two axes here, we have at the x-axis value or business differentiation, and we have effort and complexity on the y-axis. Looking at upgrades and insurances, right? How much business differentiation can we actually do with that? Well, the value is pretty high because this is upselling services. This is where actual money comes in, and this provides something that others can't provide as well as we do, or at least we can build something that they don't have. So by offering you hotels and cars, we'll do something first that no one else did before at some point. So this would be very high in value, and the level of complexity is pretty high because we have to integrate a lot of APIs from different vendors and Booking.com and so on. It has a lot of manual steps in between. So this is obviously something that we would focus on as a core behavior within our system. Core, in this case, does not mean it's the thing that brings us the most money in right now. It's the thing that we focus our core development on, right? So we want this to be better. We want to differentiate here. So this is our core system. Now, seat selection, of course, is also very important. It brings you lots of value. People can choose the right seat, and that's why they actually choose our airline, because we offer these great services. But the value of differentiation isn't that high. Other airlines will do the same thing pretty easily, and the complexity and the effort is very low. So this is more of a supporting part that we're building. It supports the core domain to actually deliver its value, but it's not the reason for being. It's not why we exist as a company. And we can structure all of our bounded context within this graph to figure out what's the strategic evaluation there, decide which we focus on as a core principle, and which ones are just supporting. And if the value of differentiation goes down enough, at some point you arrive at very generic problems. So payment with credit card is a problem I don't want to solve when I'm an airline company. I'm not going to build my own credit card fraud detection. I'm going to use another one system because it's a generic problem, right? So this tool helps you to strategize, to figure out all the different contexts we've built, where do they reside on the strategic evaluation, which ones are the ones that drive us forward into the future. Those are also the ones where more change and more force for the inertia is actually expected to come from, while the more generic things are, the more stable they will be. So we have complexity in these bounded contexts. That does not immediately have the same reflection as our strategic classification. The different kinds of complexity means we need to deal with different operating modes in those bounded contexts. And there is a complexity model called Cynefin. It's been coined by Dave Snowden, a complexity theorist from Wales. And this is a Welsh word, Cynefin. It's not Cynefin, it's Cynefin. I'm going to give you a brief introduction. There's lots more to read about on this topic, but the part that's important for me is how do we operate in different levels of complexity. So starting from clear complexity. Clear complexity means the cause and effect relationship within my context are obvious. They are very clear. If my gas tank is empty, I know a solution. Take the car to the gas station, fill it up, done, right? This is super easy. So in a clear complexity, there are best practices. We know what to do. You bring the car to the gas station, pump it up. That's what we do. That's the best practice. And the modus operandi in this context is you sense a problem, you categorize it, and then you respond by the practice that you know or get told by someone. This is also an area, and I didn't put it in writing, but this is also an area where waterfall is actually the best method. You don't want to iterate your way through feedback loops to the gas station. You just execute, right? You make a plan, you go there, you fill it up, you come back, you can check if it worked, that's great, and then you move on. And then there are more complicated contexts. In a more complicated context, where cause and effect is not immediately obvious, it's deferred, but it's analyzable. It means now we need expertise. We need people who actually maybe iterate or bring together a lot of minds to model properly. So again, with the German car example, right? I'm on the Autobahn, my car breaks down, it makes weird clanking noises and there comes steam out of it. Like, there's no obvious solution here. I'm not an expert. But I could call experts. There are people who know what to do. And they analyze, they figure out different signals, and then they can form a plan of how to solve my problem. And this is not like a best practice thing. There are good practices here. You can choose different solutions, like exchange the motor, or just fix it up with hot tape, or go there and do this. There are different practices with trade-offs to choose from. And what we do is we sense, then we analyze, and then we respond. And in a complicated domain, agile is really beneficial. So this is where feedback loops really help. You have a goal, you have a direction you want to go towards, you take steps, you keep on analyzing, figure out if you're still on track, and move from there. Now, some contexts are complex. In a complex context, cause and effect is unknowable up front. So European taxation, right? Let's make it more fair. Let's just change the rules for some countries' laws on taxation to be better for the society, and you don't know what happens next, because now companies start to reinvest differently, relocate even. People start using their money differently. Other countries start adapting their laws based on your change, and whatever happens, you will never get back to the initial state. So in a complex environment, after the fact, it's easy to analyze, oh, this is why we got here. Now I see what happened. But up front, you cannot know, no matter how much you put in of analysis and expertise. So in a complex environment, we need to be very scientific. We need to use emergent practices, things that aren't really fully formed yet, but work on methods, become tool makers ourselves, and use scientific probing. Formulate hypotheses, do stuff, figure out what works, respond accordingly, and iterate towards a more deeper understanding of the actual problem space. So this is where domain-driven design helps you most in, Agile can help everywhere, DDD can help everywhere, right? Please don't quote me to say only complex domains should do domain-driven design or such, but this is where a deep analysis and discovery really helps to understand properly what your problem space is and to formulate a solution. And then the last one, this is my favorite one to be in and also the most painful one, chaotic. If you're in a chaotic context, that means there are no guidelines, there are no constraints yet. Cause and effect are decoupled. Like you're at a children's birthday party, and the mood is kind of down, so you decide to bring in a clown. Good choice. Now, what will happen? We have absolutely no clue. It could be the best choice of your day, right? Children are already super happy, but one child starts to freak out and throws poo-poo in the wall. Someone else starts to eat the cake and the clown. Like, we don't know what's going to happen. So this is total chaos, and in this chaos, we need to come up with novel practices. Like, you can't scientifically probe a children's birthday party. I'm assuming. But what you can do is you can act. Just go with your gut feeling, right? You think, oh shit, this child is crying, let's just use another animal. Hey, look here. You just do something and then figure out what's the reaction and then probe your way towards more stability over time. So every phase that you are in has a tendency to move clockwise. So if you're in a chaotic environment, it's not going to stay chaotic forever because novel practices become emergent practices over time. If you've done birthday parties 15 times with a clown, you have an idea what will happen, so your intuition becomes emerging practices, right? And then you're in a complex environment, and if you analyze it long enough with science, it becomes complicated. So everything tends to move this direction over long periods of time. Now, why are we talking about complexity so much? Because very different modus operandi and very different kinds of teams are needed for these different contexts. If I have a chaotic context that I'm innovating in, I need people who don't want to do every second week a sprint meeting and every morning a step. Like, I need people who just like, okay, what are we doing now? What's the most valuable thing? Let's move on. I have this great idea from a conference. Let's try this out. You want to be hyper innovative and just act and do things, figure out how stuff works. While if you're in a clear domain, you want to have people that follow the rules, that understand the plan, that report to their boss, and they fill in their timesheets properly, right? That's a very different modus operandi. So understanding complexity and strategic value is super important to optimize your team topologies. Because your different kinds of teams here, X-Men and the Scooby Gang, are vastly different crowds, and you want to use them optimally in the domains and the context that they serve properly. So now, without an actual content, I'll just give you some abstract examples. So let's say we have context A to D here, and this is the relationship of the different bounded contexts in our model. We have a core domain that is very complex. Then we have a supporting domain with a clear complexity, another supporting domain that's in total chaos, and we have a generic domain that is also complicated. How do we actually put our teams in there? So, has anyone read Team Topologies? I love this conference. So, Team Topologies by Manuel Pez and Matthew Skelton. It's a beautiful book that got a lot of traction in the DDD community over the last 6 years, 4 years. I don't know how long the book has been out, but since it's been out, it has been gaining a lot of traction, saying there are 4 different kinds of teams that you can put in your context. There are stream-aligned teams that take care of customers' needs end-to-end. There are enabling teams, which basically are the facilitators and the teachers that help you get the rocks out of the way so you can do your work in your team. Complicated subsystem teams, which is whenever there's deep expertise needed, they don't care about the end-to-end flow, but they know the business rules of this specific set of cases. And they become domain experts deeply for a certain part of the system. And platform teams, this is the only non-domain-driven thing, right? You're building a large software system, and not every context should build their own message pipeline. So you have a platform team providing Kafka access or whatnot. Not a fan of Kafka, but well. And these different team structures have 3 modus of operation, right? So there's collaboration between 2 teams. This is always great when you want to do discovery together. So if you're in a complex or in a chaotic area, this is where collaboration helps a lot to figure out, okay, what are we actually trying to do here? Let's collaborate and learn and discover about our behavior. Or if you need more predictability, using another context as a service, so talking to that team basically as, hey, if I ask you a question, this is the answer I'm going to get, great. I have predictability there. And well, the facilitation is when you have an enabling team, they facilitate so that You don't have to take care of the modeling sessions and such. Now, I like the team topologies, but I find it kind of incomplete. And this comes from my philosophy of, I like using tools. Right? I like Agile, I like DDD, I like all the architecture ways, but don't just use tools, become a tool maker is what I go by always. So understand the why behind team topologies, and then you realize there are structures missing. In team topologies, we don't have a governing structure. So the C-level, right, that makes governing constraints for the company, still part of the system design, because Conway's law. Partnership crews, people that talk to external vendors, they are also part of our system design. So the unfixed model doesn't have a fixed structure. These are just suggestions, different kinds of team that exist. The top 4 ones are exactly the ones from team topologies with a slightly different name. But then there are a few more, and the open invitation to, if you find a metaphor that is missing, add it. Right? The only important thing is that in your actual map, you have a visualization of the actual structure that you care about. So here we say, look, our context, the complex context as core domain, it needs a deep capability team. While the supporting context both need a stream-aligned one, and in the generic context, we need a partnership team because it will be vendor software we'll be using. So it's more about managing a partner, not building a software system. And so far, we have focused a lot on the content of single individual bounded contexts, but a complex system isn't built from parts that work in isolation. Socio-technical relationships make or break the entire solution you're building, right? If we all start to optimize for our own local kingdom, we will lose the system entirely. We need to optimize for an entirely system optimization. That word twice in a sentence is great. So we always optimize the entire system. And to manage the system effectively, Eckhoff, right, one of the big system thinkers, we need to focus on the interactions rather than the parts in isolation. So a very simple way of expressing this is to say somebody has more power in the interaction and has more dominance or influence on this model of our communication. So in our case, the core domain, which is complex, would be upstream in influence. And the supporting clear domain is downstream. That means whatever they decide, they want to support that choice, right? They help to make it happen. If they have a wish, well, they drive the strategy, so they can absolutely say no. There is a power differentiation. So we want to see that visualized in our context map, so we can actually have expectation management and also plan for a better architecture. And just because something is core domain doesn't mean it's always upstream, because if you talk to an external vendor, right, you can wish whatever you want, but they're not going to change just because you wanted it so. So you're downstream even though you are a core for our business. And then some contexts even have a pairwise relationship where power level is equal, and you would also put that into your map. Now, this has social and technical implications, no wonder, because it's called socio-technical relationships, right? The social and technical implications here are important. This is a trap. The implications, especially on the technical part, seem like, hey, now we're going to build an API with upstream, downstream, or pairwise communication, right? But a socio-technical relationship is not an API. Even though we talked about the commands, events, and data you want to get from each other, but this is all about culture, behavior, the way we communicate, and also the technical API that gets designed by those teams. So I hope you can read it from back there. If not, I'm going to read it for you. There are 9 different default recipes, but bear with me. The same way as I said before, this is a set of tools you can use, but become your own tool maker. If those metaphors don't work for you, find your own that work. As long as your team agrees on the terminology, you're good. So we have 8 minutes left, and I have 9 patterns to get through. Let's go. Partnership. Partnership is a relationship where both teams look eye to eye level. The influence on the technical side is we don't need defensive coding. If I trust you, you trust me, we're best friends. I'm not going to log everything that you do to prove that you were the culprit. I don't care. Like if something breaks, we both meet, we solve the problem. That's amazing. This is the benefit of partnership relationship. The downside is it comes at a high cost of communication, and it requires a lot of trust. You build trust over time, but it's easy to break trust with one single action. So it's something that is great to have, but hard to maintain. It comes at a high level of cost. Harder to do in remote teams, not impossible, but harder to do. Shared kernel. A shared kernel is if we share a concept. Let's say we work all in something with banking, then there is the idea of a currency, right? That's a model we all share. So we can come together and say, this entire idea of how currency works is a model that we will build together. It doesn't have its own team owning it, but 3 different teams join whenever this needs to change. And this will be a visual part of our map because we need to see the shared ownership there. And this ownership, again, is on a technical side. We share the code base or the definitions, but it's also on the organizational side. We need to have common meetings to make these things happen, either ad hoc or regularly, depending on the need. Another form of relationship, and this is one of the most common ones, is customer and supplier. That's the classical upstream-downstream relationship. The supplier of something has more influence. The customer has less, but not zero. So if I'm supplying the model, this is not about message flow direction, very important, right? It's not who calls whom or who sends the message. This is who influences the model. If I define what messages you can send me, I'm the supplier, even though you're sending the messages. So that's customer-supplier relationship, and both models evolve together, right? But under different influences here. Your classical core domain would be a supplier usually. And then sometimes the power differential isn't just skewed, it's 100%. So if you have a model that, the blue ball here, right, and then someone else is just leeching off of that model, just using it without the other model even knowing it, then you're just a conformist. So this often happens in reporting systems, right? You have your database with all your stuff in it. I'm building reports now. By just looking at the database, I kind of guess what this means, and I'm going to make a report on it. You don't even know I do that, so I'm conforming to your model. The absolute benefit is fast movement. I can create stuff without having to talk to you. Great. The downside is if you're changing, I'm screwed. So conforming to a complex model or to an evolving model is very painful. Conforming to a stable model is wonderful. It gives me way easier pace in movement. So yeah, beware there. You're always at the leisure of someone else's model. Something we use a lot with legacy systems is an anti-corruption layer. This is a protective shell in between 2 contexts. So if I want to protect myself from your model, I'm going to build something in between that translates whatever you do to whatever I already understand. This can be technical in nature, right? You're using messages and you're always changing the nature of the messages. I just need SQL statements. So I'm going to build an anti-corruption layer that does the translation. So my model stays pure and I don't have to understand your stuff. Or with a legacy system, the legacy is not changeable by definition. So I can build a model that translates all my semantic messages and wonderful procedure calls to whatever nasty thing we need to do to make that behavior happen in the legacy. So I can evolve my model pristinely. I want to be aligned in my core domain and move fast, right? But the anti-corruption layer can take care of the ugly truth in the middle. Beware, this is a very complicated piece of technology usually, or organization that needs to be implemented. The anti-corruption layer can be bigger than the context itself, but it protects your model. And if at some point the legacy goes away, you can also remove the anti-corruption layer. There's a big strategical benefit in this that I sadly don't have time to go into right now, but happy to discuss later. You can actually use this to replace a legacy system step by step by surrounding it with anti-corruption layers until they all vanish. Okay, open host. Open host is when you have an upstream context that is benevolent. So Google Maps provides you an API to say, give me a street address, and I'm going to give you the point on the planet, or the other way around. Give me coordinates, I'll tell you which address it is. They will keep doing that, even though the API, their internal model might change. They might use different coordinate system in the future, but they will still provide the same outward API. So you don't have to protect yourself with an anti-corruption layer. They are a benevolent host with many clients, and that's what we call an open host relationship. So this, of course, requires contract negotiation and also communication when change actually happens, but they will make sure that you get there pain-free. And then the last 3, a published language. In some bounded contexts, the language itself becomes the model. So if you work in banking and you speak Swift, you can take part in the conversation without ever having to talk to the other banks and negotiate an API or anything, right? So the language itself is something that becomes part of the model, and you want to publish it in your structure. And the last 2 are separate ways and the big ball of mud. Separate ways means you have 2 different bounded contexts that should talk to each other from a business point of view, but they don't, because either technology is incompatible or because the people hate each other so much or are in different time zones or whatever that they don't want to integrate. You don't want this in your model, but if you have this in your model, you want to make it explicit, so you know that there is a lethal problem. And the big ball of mud is usually the thing that we call the legacy systems, right? It's an unconstrained boundary. So it's not really a boundary, but it's just, here's a big pile of poo. Let's visualize it, let's give it a name, and then see how we can interact it with the rest of the system. So those are the different socio-technical relationships, and now I've updated our map here. We have a customer-supplier relationship between our core domain and the supporting clear complexity. We need a partnership between the supporting chaotic system and the core complex. Because of the volatile nature, we need to communicate closer, right? And down here, well, I just invented a new method, a new pattern called vendor, but I use an anti-corruption layer to talk to a vendor system. I don't want to integrate the vendor system into my structure directly. And this is how you can design your socio-technical architecture. This is driven by the domain. All of those contexts reflect a certain part of the domain model. There's a single team in them that we can clearly define that owns this model, and it builds a piece of software that reflects the social dynamic of the interaction between those models. So far, that's the conclusion. Now, I have 32 seconds. Let's rush it. The things I want to take you away are: focus on the domain first. That's the most important thing. You are solving problems for business people or for problem havers. So focusing on the domain and building solutions aligned with that, super important. You need to provide psychological safety within your teams and your organization to be able to foster that change. And you want to nourish the agency. So it's not just about autonomy within the bounded context. Once the contexts are aligned with the domain, it's agency, right? Within our context, we have the agency to change the boundary, to change the shape, to actually restructure the organization. This is at odds with the classical hierarchical way to organize companies, and I'm happy to fight, but this is what we need to do if we want to actually solve complex business problems in the long term. And gather all the tools, methods, and heuristics you need, learn from them, and become your own tool maker by adapting the best patterns and practices that help you solve your business problems. Thank you so much. I don't know if we have time for questions.
We're going to give you time for questions.
Yes. Okie doke.
First of all, congratulations on an
much.
outstanding speech. Even I understood it, so that's
Perfect.
that's great. Ladies and gentlemen, the lunchtime has begun, but people did send in questions on Slido, and we have 6 questions. We're going to put them up, and we're going to let Marco have at them.
Is your reservation service self-contained, meaning does it also serve its UI? It depends. There's the best answer. So let me give you a quick understanding. Usually, most bounded contexts bring their own UI with them. But some companies say we need a corporate identity in all of our contexts. They should all look and feel the same. So building something like micro front ends within the context, they all serve a larger bounded context that has a cohesive design and frame around it. That's another solution. And then the third one would be to say the visual designs are made by one team in one context, but every bounded context delivers data and acts on commands and queries and events. Those are different design options you have, and this totally depends on how your company is built. If you have lots of designers, you can distribute. If not, not. Cool. Within a context of legacy systems, architecture can be too rigid to change after decades of software development and revival depth built in. Given an evolving, something is missing in that question. Two-domain, how do you effectively tackle this challenge? So this is one of the hardest challenges, so a big it depends. The general gist is deep discovery, right? I want to do a big picture event storming or whatever is needed to understand what's really happening in the legacy and what keeps us from adapting. So if we find context in there that we can extract, I'm going to use anti-corruption layers to tackle that. You can use something like a CQRS architecture where the old database becomes a read model of your new bounded context. So everything you do happens in the new context, but every change also gets projected into the old database. So the old system doesn't feel the change. This comes with a lot of technical challenges. We can talk about that in detail if you want, but that's usually what I go for. Deep discovery, figure out what you can change, use different architectures to decouple. First, we had one thing which was layered, and with bounded context, we just have many smaller things which are layered. So this is actually true. The bounded context meta architecture doesn't tell you how to build the context internally. And this is a good thing you have a choice. In some bounded contexts, all you need is a database and a smart front end. That's the best architecture for some parts of the system. In others, you need a very complex microservice architecture with lots of semantic event storing and stuff like that. And you can make those choices context per context. Usually, upfront, you don't share anything between bounded contexts. But you can, of course. If we own multiple bounded contexts and they all want to use the same database, you have a choice to say, let's bring that dependency in. But the context boundary itself should be self-contained with everything that you need to build for it. This trade-off, like every other trade-off, should just come consciously, and then it's OK. If you do it unconsciously, that's a problem. Would it be possible that a chaotic context evolves to a clear one without going through complex and complicated states? I guess, I have no example yet, but if you have something, let's say, very chaotic, and then in the chaotic process, while just acting and doing something, you realize, oh, Heureka, there's a moment I realize it's a very simple thing. Sure, you can just jump directly. I would say there's nothing preventing that, but you most likely won't find that in software development actually happening. So the natural progression in 99.9% cases go through those phases, but there is no natural law against it, of course. What's the difference between a conformist happy path relationship and an open host relationship? Actually, there's none. Those are two aisles, different sides of the aisle. I'm conforming to an open host. So in my diagram, I would say, here's an open host, put open host at the boundary, and then the other context can use an anti-corruption layer, which is kind of silly when you have an open host, right? Or you can be kind of in a customer relationship with that, or it's just a conformist to that open host, which is the most common relationship. If you're an open host, I'm going to conform to your model. That's why you're an open host. A reason against that would be if Google's interpretation of addresses and coordinates is not mine, if I have a different way. Like, I'm using it for my Minecraft server, and I have Minecraft coordinates. Now I need to translate. I'm not just going to integrate street addresses. I'm going to translate to my internal coordinate system. But the usual one is conforming to an open host. Thank you so much. Enjoy your lunch.
Thank you again.